Hi to everyone. We start our video lesson and it will dedicate to Downhole model. We made few videos regarding this model before, but this video will sum up all new and old features, and I'll demonstrate a brief workflow how to work from the beginning, from data files, SIG-Y or SIG2 to final model. So in the simplest case, we have several files which corresponds to different depths in boreholes for downhole case or VSP case, and we should import it to software. It used to have several components in different channels and trigger we have. So it's maximum 4 channels, and it can be P waves or S waves data. In case of S waves data, we have 2 files corresponding to left and right heats. Okay, I'll start with some data set. Here I have to choose this filter, VSP data, and open and select all files. It's a very simple case, only P waves data here, so just one shot. And here we have a table. First column is about using this file in dataset or not. Second, should be used for S waves data. If we have a plus and minus, left and right heats, for P wave it doesn't matter. And this one is a def. Here is very simple data set where is every file, every number corresponded to specified def. So it's the same. So we don't need to change it. It's very simple to fill these 2 columns by using Excel. Microsoft Excel, we can just copy columns to this table from Excel, because sometimes files not corresponded to this order, and or we have a left and right shot, so it's simple to copy it, not using every file to set up. So we should choose next which channel in file correspond to real components or trigger. I know about this data set that first is trigger, second is X, Y, and Z. And distance to borehole is 3 meters here. This is all I need. So, yeah, I have a X channel, Y channel, Z channel, and trigger. First of all, I need correct zeros in this file, because sometimes it has a not normally leveling. And now if I have a not straight trigger times, I can pick it and add these values to every trace. So correct 0 time on traces. It's very simple for trigger because, oh, sorry. It's about here, because we have here normal trigger time, and now it's picked normally and very This very exactly trigger time. You can check it. Just smooth a little. And now I can set these trigger times to all traces. These options are right here, apply trigger shots. And now I don't need this shot. I'll remove it. Okay. Now I have a 3 shots, but for P waves data, I need only ZZ shot. And I'll also pick it. This is my travel time curve. So all I need now to check this data in VSP model. So it's can be inverted. It's very small misfit, so it's good. But what we can also do, we can invert not only travel times, but amplitudes. For this, I need to pick amplitudes from this data shot. So I should check for wideness width of my amplitudes, and it's approximately 3 milliseconds. So I will set it up here, 3 milliseconds after T0. And now I can make collection of amplitudes data. Now I can check it here, how it looks like. Yes, I see there is 2 points, not very good. But I should say that amplitudes is not so good, has not so good quality for VSP or downhole data, because we have a different shot stray or power for every trace, because it's different hits. Every trace is different hits, so this data can be very noisy and not correctly leveled. But you can try it. It's some extra information. It could help or not. Because for example, for Crosshole data, it's very good if you have a possibility to invert this data together. Okay, to invert both data, travel times and amplitudes, they need to go to main window. Here I have my model, and also this model can be run from here, downhole model here, and I can see both travel times for VP and amplitudes for P waves. So I can do joint inversion because amplitudes are connected to velocities. So it's maybe good or not. I don't know how it will be, but let's try it. Okay, here is velocity model, and this is predicated curves with no points. Points is measured data. So this is model, and you can see here both models of parameters in table. It can be copied or saved to file or copied to Excel. So some people doesn't like this system when we have a lot of layers correspond to Z position in borehole. So you can choose layers number by yourself, and this option, this lighting. For example, I can choose 6 layers, for example, and after it I should press this button. Now I have this more simplified model, and I can do some kind of modeling to check how it looks like. It's, as you see, after every changing these two curves recalculated, and they can do modeling. Also, they can, for example, split this layer into 2, or we can merge 2 layers to 1. Also, for inversion, we can fix depths to specified layer, or we can fix velocity. It will be gray if it's fixed, and it's any change in inversion does not apply to it. So I can fix some random cells and trying to do inversion. Okay, it's not that good because it's fixed on some stupid values. And also I can do separate inversion only for velocity. In this case, I should turn off this checkbox. So only if I check these boxes, it will be involved in inversion. So, and no difference for this model for attenuation. Okay, here also options invert depths. It's turned on automatically if I choose a user-defined layers number. This means it's not only velocity will inverted, but also depths of layers. So these options control smoothness of velocity model. So if I choose maximum smoothness, it will be not so many features on this model curve. Or if I choose minimum, it will be something else, and it's maybe a lot of layers, visible layers on this curve. So robust mean they can allow to inversion make a big contrast between neighbors layers. So this turn on possibility for such high contrast borders. Okay. So this is how this model work for simple data set. So now I will try to open another data set, because data set can be collected in one file, and I can open it from there. This is one file, and all geometry already included in this segue file, but there is a little difference because in zone software we use negative values for depth, so you should change sign of depth right here. Now it's negative sign, and now we can pick in data it's picked well. There's some noise. And we can do again. This is amplitude collection on these options and see how it looks like. Now do the same thing if we want to invert together velocity, travel times, and attenuation. So I go again to downhole model. I see both curves, and I can. There is, I think, not enough layers, so I will make, for example, 12 and do inversion. Cool. Normal smoothness factor. This is how it looks like. My model. Maybe it's not good enough, but we just demonstrate possibility of interface. So now what I can do, for example, I can do correction of this curve because downhole is full of some rules. So amplitude should follow up for every point below after some depth, of course. Because here we can have some kind of refraction for first 3 points, 4 points. But here it should be only a lesser every point, and we can do this correction. Now it's corrected data. So I will set to normal model this fixed depths. And now I'll try to do inversion. This is what I have after several iterations. Misfit is quite good, but does this model realistic or not? I don't know. It's too many extremes. So now I can copy this model to main window to see is it okay or not. And you should remember that I corrected data. It's only internal in this model. It doesn't affect on the amplitude dates outside this model. And now I have this inverted model here. Let's check. This is very good misfit. And I can do inversion in main window, but actually I don't need it. Okay, and let's check attenuation. Yes, it's a little different because we have correct our data. All these steps supplied, and this is how our predicated data looks like in downhole mode. Okay, we can do inversion again here, but we don't need it. Okay, now we will check for another thing. It's extra bonus. In downhole model, we can use it for crosshole data. For example, here I have some crosshole data. There's a lot of travel time for this. So I will not pick amplitudes here, just a travel time data. This X and Y coordinates, location of downholes. And now I can go to downhole model. This is amplitude data. It's orange color, but we don't need it because it's incorrect. Now we can do inversion. For example, there is 20 layers. Let's see what happened. Because here is a lot of data and inversion, not that fast. Oh, sorry, I forgot to press this button, so it's not 20 layers, but it's like a lot of layers. So inversion is very time consuming. But let's wait till it's finished. Maybe a couple more iterations. As you see, it's maybe quite good first approximation of model. So it can be copied to main window to make 2D inversion of such data. Yes, possible. It was 20 layers. It will be much faster. Okay. It should be last iteration. Okay, it's finished finally. And I can copy model to main window. Now I have very good first approximation for inversion. Let's check it. Yes, this is how this model looks like in forward modeling. And another option here, we can put only selected curves to a model if we have several, for example, for downhole, sometimes several curves, we can choose only few, 1, 2. So we should, in this case, choose this option, invert visible data. And now we can choose just several, which we want to add to inversion. For example, this one. And I'll go to downhole model again and see only this curves. And let's me make this only 20 layers, good. And now inversion should be very fast. Okay, this is result for only this travel time for this. Now I can copy it. It's very close model. Yeah, we can check it again. Maybe this is enough. Okay, and I have one project where I have both data sets for P and for S waves. Of course, if you work with many files, sometimes it's more comfortable to work separately with P and S data. After that, you can just add, for example, P project to S project. It is here, add to project, and this made merging of two projects with P and S waves, or otherwise you can use all data in one project, so it's no problem. Here I have the P and S waves in one project. It's text file and it's already picked. Very simple VSP data, and now I go to downhole model, and I can see both for this. It's maybe maximum four for this for maximum four data types. It can be VS, VP, AS, and AP. Of course, it's much more travel time curves or amplitude curves inside, but it's maximum four data types you can invert. I see here is some wrong points, and I can remove it from inversion. I should press Alt key, and then I will see this circle, and circle allow me to select or deselect some points I don't like. So mouse wheel, as usually, for changing size of selector. So now I have these two curves, and I can do joint inversion. It's joint inversion because I actually invert data through the Poisson ratio. So they connected each to other, and resulting models Poisson ratio couldn't be out of normal range. So let's check. And here is Poisson ratio. We can switch to Poisson by double click to see how it looks like. Or I can invert it separately. For example, now I will invert only VS data. And now only VP data. And I got different models for joint inversion and for separate two inversions. And here I forgot to say this. This is VS parameter for this model. You can see right here. So thank you very much. This was all about downhole model and its new and old functions. And see you next time. Bye-bye.